Let's see what chapter 5 is about. Quantum measurement. Wave function. Sunlight. Quantum world. Measurement. Quantum state. States of energy. Angular momentum. Magnetic quantum number. Quantum numbers for energy. Oh, there's the quantum numbers. So it seems weird. They're talking here about the electron in an atom. Quantum superposition. Schrödinger's equation. Measurement. Particle appears in a specific state. All the possible quantum states have vanished. Collapsed of the wave function. So what is happening here? The various quantum states. Energy, angular momentum, magnetic quantum number. So the magnetic quantum numbers, I'm not sure if that's about to spin. Collapse on measurement, you find it in a specific state. Very strange, very strange. All possible states, and then it's just reflecting that we can't say if it's in this state now where it's going to be next, it seems. Can be in any possible state. Superposition of many quantum states. Something about superposition. The full state contains far more information. What happens to all those states? And then the cat in the box, alive or dead, Schrödinger's cat. So there's various states. State of superposition. Until you measure, then you find it in a specific state. Cat in the box. Eugene Wigner. More complicated experiment to test whether the real world can be a mixed quantum state. Are all the states present? Seems that's what it's pointing at. There's a cat in the box. Live cat and cat. State already collapsed. So it's all these various states, and then when you measure, you find only one of them. What has happened to the other states? Paradox. Polarization states, 3 photons. Polarization of photons. So now instead of a cat we have a photon. It can be in various states. Superposition. So that concept that they're discussing here. Wigner's paradox. The first time I hear about him, I haven't heard about him before. Eugene Wigner. Tannery, X-ray crystallography. Oh, it's hot today. I'm gonna spray myself with water, especially my head. Okay, I sprayed myself with some water. Feel a little bit better. Symmetry, group theory. Lolo. Symmetry. It seems he was from a different country. Of course, they talk about, or he went US citizen, local realism. What is that about? Diffraction, single slit diffraction, single slit. How does a particle decide what to be? One experiment may set up to measure the de Broglie wavelength of an electron, while another set up to measure only its property as a particle. So, wave particle measurements. How does the electron react? So is it a wave, is it a particle? It's got both behaviors. Photon is emitted by a laser and passes through two slits, double slit, interference pattern, photon, double slit. Let's hope I can get to grips with this. And lots of writing, writing, okay. Particle, nanoseconds, photon, absolute zero, Wheeler, laser beam splitter, satellite system, measurement, local realism. Slits, laser beams, photons, splitter, local realism. Delayed choice experiment. Observer is present or not. Observer. Mixed superimposed state. De Broglie proposed that matter waves and particles were not incompatible descriptions, because the matter waves, which he called pilot waves, a signature of an underlying theory whose details we have yet to discover, and provide the missing parameter to make description fully deterministic. Particles in an entangled, superimposed quantum state. Opposite polarization, maybe entanglement, annihilation, entangled, quantum mechanics, Stuart Bell. Quantum mechanics was incomplete, was also incorrect. John Stuart Bell proved that the second interpretation of quantum mechanics was incomplete, was also incorrect. '78, correlated electrons. Bob and Alice, source. Is it entanglement? Quantum relativity, which is that information cannot travel faster than light. Predicted polarization, measured spin, inequality, hidden variables. Now we're getting into the thick of it. De Broglie's pilot wave. Experiments. Seems they did some experiments of entangled electrons. Stuart Bell. A larger theory that provides missing information. Local realism is very strongly disallowed, and the peculiar nature of quantum mechanics appear to be firmly established. So something that was very strange, we have to accept it. fixed properties until the moment of observation. This behavior is not caused by quantum mechanics being an incomplete theory that needs to be patched up with a superior theory that can provide the missing information. The choice of questions posed by the experiment at the instant of interaction was the detector. Are you a wave or a particle? Determines the property of the particle independent of the paths taken by the particle. And there are the key points. Quantum superposition, Copenhagen interpretation, until the moment of observation a particle can be in superposition of more than two states at once. Two particles can be in a single superimposed state, in which the measurement of the state of one particle immediately places the other particle in a definite state. So this meaning that they are superimposed, both of them, and only when you measure one, they both collapse immediately into their quantum states. Quantum entanglement, Bell's inequalities, photon or electron, local reason cannot be built into quantum mechanics using hidden variables to eliminate the need for information transfer to be faster than light, as it's seemingly required in the delayed choice experiment. This is going to be a tough chapter, but at least I know a little bit more what is waiting for me. Trying to get to grips with this chapter 5, quantum measurement. So this was the scoping session. I just try and have some idea of what is this about.